Hello, everyone, and welcome back. We are working through the MCT4C course. This is the Math for College, Math and College Technologies, grade 12. We are on Unit 4, and this is Lesson 18, Part 2 of 2. So in the last lesson 18, we had a look at the area of simple shapes, simple and composite shapes, as well as applications. Now we're going to be looking at the area of simple and composite shapes, but with respect to surface area in 3 dimensions. And so consequently, our topics for today will include the introduction to surface area. So we'll be going over the formula for the surface area on a variety of shapes, going through those, and then having a look at some just basic applications. In general, you'll know things have gone well when you're able to determine the surface area of simple and composite shapes and solve their corresponding applications. And so, what is surface area? Well, surface area is a measure of the area on the surface of a three-dimensional object. And so the formulas for the surface area of various composite, or I should say simple shapes, are shown right. Note that the formulas for these shapes are the result determining the area of each side and adding them together. So if you notice on the right side here, we've got the formula for the surface area of a cylinder, which is the area of the base, pi r squared, the lateral surface area, which is the area around the outside of the cylinder, which is 2 pi rh, and then just adding them together. Note that if there's the area of the bottom, there's the area of the top. So there's 2 pi r squared and 2 pi rh. And here are all their corresponding formulas. Now, it's worth noting one of these is not quite as intuitive as the others. That is the sphere. Sphere has to do with how we calculate its volume. And actually, there's actually quite a bit of complex math that goes into its calculation. But for our purposes, it's a very simple surface area calculation, namely surface area is equal to 4 pi r squared, and then so forth. So I will be writing out the formulas as we need them in order as we go through these questions. And again, we have a variety of simple shapes for us to go through. Okay, so I want to look at one of these and try to determine where the surface area formula comes from. So let's have a look at the rectangular prism. So it has as a formula, A is equal to 2 times WH plus LW plus LH. So where does this come from? So if you have a look at this shape here, I've labeled the three corresponding sides W, L, and H. And so the surface area would be equal to the sum of the corresponding areas on the side, on the front, top, side, and so forth. Okay, so let's have a look. So if you see a rectangular prism, that's a three-dimensional rectangle. There are a total of 6 sides altogether. Okay, and so we go through these shapes one at a time. So if we have a look at, say, the front side here, well, let's put that in red, I suppose, so it's easier to see. Let's have a look at the front side here. The area of that front side is H times W. And so the surface area will be H times W. But if you notice, there is a front side here, but there's also going to be a corresponding back side. So there's actually two of them that use the exact same measurements. So we will label this as 2HW. Similarly, if we have a look at the top of this, the dimensions of the top of this thing have uh, a length of a width and a length. So we can say add on the length times the width. But again, there are two of them. And using similar reasoning, if we're looking at, say, the side of the shape, it has as length and height. And so we can add on the length times the height. And again, there are two of them. Now, if you notice, all three of these expressions happen to contain a 2. And so the surface area will be equal to a 2 multiplied by HW plus LW plus LH. And if you have a look here, this matches up to what the formula is going to be. The only thing that's different though is they switch the position of W and H. So if you so choose, we could write this as 2 times WH plus LW plus LH. I'm not sure why they write it out as WH, because it should be in alphabetical order, but the formula sheet, for whatever reason, lists it as WH. So there you go. So I suppose we have that consequence. Okay, so I'll be referring to the formulas of these as we go ahead and solve a basic example of all of those. And then we'll go from there. So we wish to determine the surface area of the following simple shapes. And we go all the way down to F. Okay, sounds good. So here we have that rectangular prism. So we know that its surface area is equal to 2 times, and I think it was WH, plus LW plus LH. And all you do is just assign a corresponding measurement to each of those variables. So most people are quite happy to call the 2H. I guess the width could be 7 and the length could be 8. And so our surface area will be equal to 2 multiplied by WH. So this will be 7 times 2 plus sign the length times the width. So this will be 8 times 7 plus the length times the height, which is 2. You could also write this, if you're interested in an alternative method for writing these things down, you could use the multiplication sign and call it 7 times 2 plus 8 times 7 plus 8 times 2, like so. However you want to write this out, typically this question is worth a couple of marks. And so at this point, you only get 1 mark for getting the correct solution once you've written down what you need. So using the Desmos scientific calculator, we can write this as 2 multiplied by 7 times 2 plus sign 8 times 7 plus sign 8 times 2. And so you can see we get an answer here of 172 centimeters. Now, since we're dealing with surface area are units squared. So these will be square centimeters. Note we could have typed this out using the bracket method that I alluded to as well. And this would work as well just as fine. So whatever you prefer with respect to typing this in, and I do encourage you to practice typing these in as we go through them, just to make sure you're able to get the same answers I do on your calculator. Okay, so that's letter A. Let's try out letter B, that's a cylinder. So its formula is going to be our surface area is equal to 2 pi r squared plus 2 pi rh. And just like before, it's worth noting that we're going to write pi to be equal to 3.14, and we're going to take 2 decimal places where necessary. Now for this question, we were given the diameter, so the radius will be equal to 2.4 divided by 2, so that's going to be 1.2, and the height is 5. And so the surface area will be equal to 2 multiplied by 3.14 times 1.2 squared plus 2 times 3.14 times 1.2 times 5. Okay, so we could type this in on our calculator. 2 multiplied by 3.14 times 1.2 to the power of 2 plus sign 2 times 3.14 times 1.2 times 5. And so we get our surface area answer to be equal to 46.7232, which we can claim is equal to about 46.72, and this will be in meters squared. Again, when in doubt, if the question doesn't stipulate, usually 2 decimal places is enough. And if you were to use the pi button instead of using 3.14, your answer would be slightly larger than what you should be getting. Okay. So what about the triangular prism? So here, the formula, and it depends on what kind of triangular prism you have, But essentially what you need to do here is find the area of the corresponding three rectangles that make up a triangular prism, as well as the faces. So we have this formula here. Okay. And so this is going to be our triangular prism, what we're going to look like. This one's actually called a right triangular prism. And we just have our rectangles. So let's say call uh, 8 will be our base, 6 will be our height, 10 will be, say, C, and 12 will be A. Okay, because I think they used A, B, C. They did. And so we'll just label it like such. But again, when I see these kind of questions, I just want to it seems it's a bit more helpful just to kind of reason out what they are. So the surface area of this should be equal to, well, there's two faces here of this 6 times 8. So we should have 2 of this height times height times the base, or base times height. And it's a triangle, so we have to divide it by 2. Now, if you notice here, the textbook only just writes this as BH, and that's for this reason here. Because we have two triangles, so the area of a triangle, and I'll put this in red for the moment, is supposed to be base times height divided by 2. But since there's two triangles, the 2 ends up canceling. So actually on the next line, this ends up being base times height, like so. Okay. All right, what about the next one? Well, we have a times a C, so that'll deal with one side. What about the bottom of this? Well, that's an A times a B. And what about the backside here? Well, that one's just going to be a 6 times a 12, otherwise known as A times H. And again, you can see this does match up. There's BL, AH, BH, and CH. So this matches up to what we were doing. Again, the only thing that varies slightly is that just depending on how you orientate your variables, it might be slightly different. But again, the way to think about this is just to like get all of the areas and figure them out together. Okay, so this surface area, so base times height, so that's going to be 8 times 6 plus A times C, so that's going to be 10 times 12. A times B is going to be 12 times 8. And A times H would be 12 times 6. So this surface area will be equal to 8 times 6 plus sine 10 times 12 plus sine 12 times 8 plus sine 12 times 6. And so we get that the surface area here is going to be equal to 336 centimeters squared. And so with respect to surface area, the triangular prism by far is the most difficult one to do. And it's just because the formula, when it's simplified, doesn't feel as intuitive as the other ones because there's these random sides and you have to account for the height. So there you go. Okay, let us continue on. Next one's a sphere. This is by far the most pleasant of them. The surface area of a sphere is equal to 4 pi r squared. That's it. 4 times the area of a circle. Okay, so here it's worth noting that the r is equal to 9. So our surface area will be equal to 4 times 3.14 times 9 to the power of 2. So we like seeing spheres. Spheres are by far the easiest one to do. Times 9 squared. Okay, so our surface area is going to be 1017.36, and this is going to be in centimeters squared. So overall, we know that things have gone well. Okay, let's do letter E. So E is a cone. So if you notice here, it's going to be pi r squared, but plus pi rs, where S is the slant and R is the radius of the circle. You actually don't need the height of a cone, as it turns out, but we do need the slant. And so here, the slant is S and the R is going to be 8. Was it pi r squared plus pi rs? Yes. Okay. So the formula here, the surface area will be equal to pi r squared. So this is the area of the base plus pi rs, which is going to be the surface area of the slant, or of the lateral surface area of the cone, I should say. And so we have 3.14 multiplied by the radius, which will be 8 to the power of 2, plus 3.14 times the radius, 8 times the slant, which is 20. And I like using brackets because it kind of they're easier to match up in the Desmos calculator to what I'm writing down. And so I do uh, prioritize having clarity with respect to what I type in. So if I take 3.14 times 8 to the power of 2 plus sign 3.14 times 8 times 20, I get that the surface area of this thing is equal to 703.36, and we're dealing in centimeters squared. Okay, so those were 5 examples I just kind of pulled. The last one I pulled from the textbook. So this is the square base pyramid. And so the formula for this, for a square base pyramid, is b squared plus 2bs, where s is the slant and b is the base. So the surface area is equal to b squared plus 2 times bs. So s will be the slant and b will be the 9. So you might be wondering, where does this formula come from? Well, if you notice here, the area of each individual triangle is just going to be the base times the slant, which will be 2. But keep in mind, there's going to be 4 of these. So one triangle is b times s divided by 2. 4 triangles, or 4 times a, is equal to 4 times bs divided by 2. The 2 goes into 4 twice. So that's why it's 2 times bs. So essentially, you're finding the area of 2 rectangles instead of 4 triangles. Because if you cut a rectangle diagonally, you get a triangle. And so we type these things in, and then the b squared comes from the base. So that's the area of the bottom rectangle. So the surface area will be equal to b squared, which will be 9 to the power of 2, plus 2 times 9 times 11.3. Okay. No, I was just double checking that I was recording. I recorded a video earlier and I lost my audio, so I just wanted to make sure. Okay, so we type this in. So our surface area will be equal to, so we take 9 to the power of 2 plus sign 2 times 9 times 11.3. And we get the surface area is equal to 284.4, and this will be meters squared. Let's type that M maybe a bit better than what I did. There we go. Okay. So those are all the simple composite shapes. Sorry, the simple shapes. So we've done one of each example. So let's see what happens when we start combining these. So now we're going to determine the surface area of the following composite shapes. And so I've got 3 of these, including one from the textbook. And composite shapes also could just be more complicated. So we'll see that in action. So letter A here, we have the silo. And so that is a cylinder with half a sphere on top. So this is what we call some people call it a hemisphere or semisphere. But if you're not sure which term you should be using, you can just call it half a sphere is the easiest way to think about this. Okay. And again, like I've heard people call them all of these things. You should just use the most correct name is hemisphere. So just keep that in mind. Okay. And we have a cylinder on the bottom. Now, keep in mind, though, this cylinder, I guess I'll write this up here. I could say that's okay. The cylinder, okay, so let's talk about this. So we have half of a sphere, and it's placed on top of the cylinder, which means we don't need this part in the middle. So this that I'm shading in red, we don't need that surface area. So instead of needing 2 pi r squared, we only need to find the area of one circle, not two circle. So the cylinder has half a sphere placed on top. Therefore, we do not need the top area of the cylinder. Okay. And so just like what we did before, we now have two shapes we're worried about. We would like to find the surface area of shape 1. So the surface area of shape 1, that's going to be the cylinder. And so normally it should be 2 pi r squared, but it's just now going to be pi r squared plus 2 pi rh. So here r is equal to 6.5 and h is equal to 14. So here we will have 3.14 times 6.5 squared plus 2 times 3.14 times r, which is 6.5, times h, which is 14. And so typing this in, we have 3.14 multiplied by 6.5 squared plus 3.14, 2 times 3.14 times 6.5 times 14. And so we'll round this to 2 decimal places. So the surface area of the first shape is equal to 704.15, and these are going to be centimeters squared. So just keep in mind that this found the surface area of this lateral portion, as well as the surface, the area of the base of the cylinder. Okay, surface area of the hemisphere, that one's much more straightforward. So the surface area of the second shape, well, that's just going to be 4 pi r squared, but we only need half of it. So we just divide it by 2. That's it. So here, this is going to be 4 times 3.14 times the radius, which is 6.5 squared, division sign 2. And so when we type this in, we have 4 times 3.14 times 6.5 squared, division sign 2. So that surface area is equal to 265.33 centimeters squared. So the surface area total will be equal to the surface area of the first shape plus the surface area of the second shape. So that's going to be equal to this 704.15 plus sign this 265.33. And if we add those together, so 704.15 plus 265.33, we get a total surface area of 969.48, and these are going to be in centimeters squared. So we'll go ahead and box this as our answer. So again, relatively straightforward, but can be confusing on occasion. Okay, let us continue on. So here we have just a hemisphere. So now we've removed the cylinder. And so we have two shapes then. We have the half of the surface area of a normal sphere and actually just the area of a circle. So we can say that our surface area total will be equal to the surface area of the first shape plus the surface area of the second shape. Technically, it's area of the second shape, but again, I think for consistency today, we'll just write this as surface area. Okay, so surface area 1, we saw the formula for that from above. This is going to be just 4 pi r squared division sign 2. So here, our radius is equal to 7. So the surface area will be equal to 4 times 3.14 times the radius, which will be 7 to the power of 2, division sign 2. So the surface area will be equal to 4 times 3.14 times 7 to the power of 2 divided by 2. And so you saw here, if I could have just stopped at this point, I would have got 615.44, but I need to divide it by 2 to get my answer, 307.72, and these are going to be centimeters squared. Next thing I need is the surface area of the second shape, which is just the area of the circle. And that's just going to be pi r squared. So this will be 3.14 times 7 to the power of 2. And when we type this in, we have 3.14 times 7 to the power of 2, and we end up getting 153.86. And these is going to be centimeters squared. So this total surface area will be equal to 307.72 plus 153.86. And when we add those together at high speeds, 307.72 plus sine 153.86, we end up getting 461.58. And again, these were in centimeters squared. So we'll go ahead and box our answer for these. So these have more steps to go through, but again, we don't need to be as concerned about them. Okay. Now, this one came from the book. I believe this was a support question. Here we have two shapes. We have a cube. So surface area 1 is a cube, and surface area 2 is a cylinder. So we have a situation. We have a cylinder sitting on top of a cube, and we need to find the surface area of this whole thing. Now, if you're not familiar with the surface area of a cube, it is the normal, you can just use the same formula as before, 2 times length times width plus the width times, length times W, length times height plus height times width, just that normal formula. It's just that, keep in mind, for this one, they all end up being 8. So this formula will simplify down to actually 6 times the area of one side. But again, if you didn't know that that was the case, feel free just to use the regular formula as is, and that will not lead you astray. Now we should talk about, though, the cylinder. And so this is where the interesting part comes in. So how do we find the area of that? And we'll call this one surface area shape number 1. Because I don't want to start solving this until we've kind of cleaned up what we need to talk about. And so we don't need the bottom of the cylinder, right? So we don't need the bottom of the cylinder because it's sitting on top of the cube. And well, what about the top? Well, if you notice here, the top of this cylinder is actually just the rest of the top part of this cube, right? So if you were to squish the cylinder kind of inside of the cube, the top of the cylinder would be the leftover portion of the cube. And so we actually don't, for surface area shape number 2, we don't even need the formula for the top or bottom. In fact, all we need is the lateral surface area. So for the surface area of shape number 2, we can just say we just need the lateral surface area. The reason for that is the top of the cylinder is already accounted for in the surface area of the top of the cube. And so surface area 2, relatively straightforward. That's just going to be pi 2 pi RH. So if you remember from the very beginning, we don't need to, we only need, that's the lateral surface area. So we just need the 2 pi RH because the 2 pi r squared is already accounted for. Okay, so let's go ahead and solve these. So for surface area 1, it's going to be 2 times, now these are a whole bunch of 8 times 8s. So 2 times 8 times 8 plus 8 times 8 plus 8 times 8. And so when we type this in, 2 multiplied by 8 times 8 plus 8 times 8 plus 8 times 8. And that's going to give us 384 centimeters squared. But the other way we can actually simplify down this calculation, and I'll put this optional part, since some of you might be interested in this. So we have an optional simplification. And let's just, yeah, we'll write this in green. That's okay. So optional simplification. Okay, so we have 8 times 8 times 8 plus 8 times 8 plus 8 times 8. So there's actually 3 of them, right? So it'll be 2 times 3 times 8 times 8, right? Since we have, so you could think about this as 1 squared plus 1 squared plus 1 square equals 3 squares. And then 2 times 3 ends up being 6 times 8 times 8. So that's actually the simplification for that. And if you were to type this into your calculator, 6 times 8 times 8 gives you that same answer of 384. So that's a way you can simplify this down. Algebraically, you arrive at the same conclusion once you realize that essentially in this case, all the sides of the length. So this would be 2 times L times L times L times plus L times L plus L times L and so forth, which ends up being the same thing. Okay. So to continue this on, for the lateral surface area of the cylinder, this will be 2 times 3.14 times the radius. Now in this case, they told us that the diameter is equal to 3. So the radius will be equal to 3 divided by 2, which will be 1.5 centimeters, times the height, which is 5. And so if we type this in, 2 times 3.14 times 1.5 times 5, we get 47.1, and this is in centimeters squared. So our total surface area, SA total, will be equal to the surface area of the first shape plus the surface area of the second shape, which is going to be that 384 we had from earlier, plus sine that 47.1. And so when we add these together, 384 plus 47.1, we end up getting 431.1 centimeters squared. So this will be our essay total. Okay, so at this point here, all I have left for us to do is to try out a couple of examples that pertain to applications, and that's going to be a good stop for us today. And with these three questions, with this lesson plus these three application questions, you should then be able to reasonably go through lesson 18. So let's have a look. So sometimes you get questions just like this. So we have the surface area of a box that has length 15 centimeters, width 15, and height 7, and it just wants you to answer these kind of questions. So when in doubt, my first recommendation is always try to sketch a diagram. Since it's not always clear what the question wants, and I find that having a picture of the thing you're trying to work with tends to make it easier. So here we're talking about a box, right? So I suppose a box might be a rectangular prism. And we'll put our dotted lines in the back. There we go. And so we have a length of 15 centimeters, a width of 12 centimeters, and a height of 7 centimeters. And we need the surface area. Okay, simple enough. The surface area is going to be equal to 2 times length times width plus length times height plus width times height in some order. I might have these slightly off, but it's the same answer in the end. Our surface area will be equal to 2 multiplied by. Now, in our diagram here, let's label the 15 the length, the 12 as the width, and the height as 7. And so consequently, this is going to be length times width, which will be 15 times 12. Length times height, which will be 15 times 7. And then width times height is going to be 12 times 7. And so the surface area will be equal to this calculation, 2 multiplied by 15 times 12 plus 15 times 7 plus 12 times 7. And so I get here that this will be 738 centimeters squared. And again, we'll just go ahead and box our answer so we're clear about what our solution was. Box around the box. Very good. Okay. So when in doubt, recommend sketch that it kind of helps the situation, make it easy. In this case, may be necessary, but a useful step nonetheless. Ooh, all right. We have a closed cylindrical container, has diameter 7 centimeters and a height of 11 centimeters. The material used costs 44 cents per square inch. So already we should be mindful of the fact that we have to do some sort of conversion here. And we need, what is the cost to make 10 containers? So this is a multi-step problem that we need to go ahead and solve. But again, the easiest thing for this kind of question is just to, again, just draw a sketch. So a closed cylindrical storage container. So we have to draw a cylinder. Oh, I moved my pad here. There we go. Okay. So it has a height of 11, and we have a diameter of 7. So diameter happens to be all the way across. So we have D equals 7 and a height of 11 centimeters. So D is equal to 7 centimeters and the height equal to 11 centimeters. Okay. Now, next thing it's worth noting for this one is that we actually will need 10 of these in the end. So just keep that in mind at some point that we need to account for how many we need in the form of multiplying by 10. Okay. So far so good. Doesn't seem to be any too major of a problems. So this says that it's going to be a closed cylindrical container. So this will be the normal surface area formula for a cylinder. So we can do that, no problem. And let's begin. So if the diameter is equal to 7, the radius will be equal to 7 divided by 2, which is 3.5. So the surface area of this will be equal to 2 pi r squared plus 2 pi rh. So this will be 2 times 3.14 times 3.5 squared plus sine 2 times 3.14 times 3.5 multiplied by the height, which is 11. So at this point here, what we would like to do is to go ahead and type this into our calculator. So 2 multiplied by 3.14 times 3.5 squared plus sine 2 times 3.14 times 3.5 times 11. So the surface area of this is going to be equal to 318.71, and this will be centimeters squared. Okay. So the conversion formula, since we're going to need that, because at this point is, well, we can do two things. We can either convert the surface area now, then multiply it by the money, or we can multiply it by 10, then worry about the money. My recommendation for this is let's just do the conversion now. And then, actually, no, let's multiply it. Let's get 10 containers now and then convert afterwards. So 10 containers would be equal to 10 multiplied by 2, oh, sorry, not 2, 318.71 centimeters squared. This calculation is pretty easy to do. That's what's going to be 3,187.1 centimeters squared. And here's the conversion we will need. So we know that 1 inch is equal to 25.5 millimeters. And we know that there's 10 millimeters in 1 centimeter. So 1 inch is equal to 2.55 centimeters. Okay. And if we want to have one-inch squared, because remember, when we talk about converting areas, you need to use the conversion twice. So 1 inch square is equal to 2.55 times 2.55, which is equal to 6.5025. And this will be centimeters squared. Oh, I seem to be running out of space on this one, but it seems to happen to be quite a bit. Okay. So here we know that 1 inch happens to be 6.5025 centimeters squared. So we're curious how many inches there are in 3,187.1. So solving this equation yields that x will be equal to 1 times 3,187.1 divided by 6.5025. So again, I'm just running out of space. So I'm just keep in mind you want to be using that chart that we learned about in the last lesson where we had to multiply these things out. Okay, and so let's go ahead and convert this. So we take 1, multiply it by 3,187.1 divided by 6.5025. And so this is going to be 490. And we'll just round this off, I suppose. 490.13. And this is going to be in inches squared. And so the total, which we'll write in green, so it's 44 cents per square inch. So the total is going to be 490.13 times 44 cents. And so if we take our 490.13, multiply it by 44 cents, we end up getting that this particular project is going to cost $215.66. So this will be the total cost. So this question is quite involved and actually uses knowledge from our last lesson to solve this. So again, quite a few steps. And when I do this lesson in the future, I'll make sure to give us some more space. So that will be corrected in the notes for yourself. I'll make sure to just have this question take its own space. Okay. Last question. We have Eric is manufacturing shape of a cube with side lengths of 2.5. He drills a hole with diameter 1 foot through the center of the top to hold the umbrellas. Determine the surface area of one umbrella stand. Okay. So we have a rectangular prism. Oh, not bad. There you go. And now we have a slight, oh no, we're using the same unit, so we're okay. So each of these corresponding sides is going to be 2.5 feet, like so. We actually, well, that's fine. We'll just leave it like that because that's okay. So all the sides are equal. No, I'm going to get rid of those. There you go. So this is 2.5, this is 2.5, this is 2.5, but we cut a middle out of the top of one. And that hole is going to be one diameter, 1 foot diameter. So that's going to be 1 foot. Okay. So we need to figure out what the surface area of this whole thing is. So this looks like the surface area of a rectangular prism minus the area of the circle. And so we'll write it down here. The surface area total will be equal to the surface area of the cube minus the surface area of just the circle, right? We're not worried about the thickness of the circle. We just worried about how much circle's on top. Okay. So surface area of the first shape is just a rectangular prism. And the surface area of the second shape was a circle. Okay, so for the rectangular prism, it's 2 times LW plus LH plus width times height. So that's going to be 2 times 2.5 times 2.5 plus 2.5 times 2.5 plus 2.5 times 2.5. And using that trick I showed from earlier, we're just going to say there's actually 6 of these. So it'll be 6 times 2.5 times 2.5. And so my calculator, if I type that in, 6 multiplied by 2.5 times 2.5, I'm going to get here 37.5 square feet. So this is actually quite large. Okay. Surface area of the hole. Now, they told us the diameter is 1. So if the diameter is 1, the radius will be equal to 1 divided by 2, which is 0.5. So that surface area is going to be pi r squared, which for us will be 3.14 times 0.5 squared. So that surface area will be equal to, and on our calculator, we can type 3.14 multiplied by 0.5 squared, 0.785, which will round to 0.79. And so we just got to subtract these. And cancel. Okay, I was like, oh, I hope we didn't lose everything after we went through it. That would have been a disaster. So we're going to minus 0.79 from the surface area of this cube, which is going to be 37.5. And so with that, we're going to have here 37.5 minus 0.79. And this is going to be, so altogether, this is how much we need in order to, this is how much material we'll need for one particular umbrella stand. So with that, that's a good place to stop for today. So you should be now comfortable to go ahead and complete lesson 18. Lesson 19 is going to be perhaps our shortest lesson we'll have for you. So with that, if you have any questions, please feel free to reach out, but I will see all of you next time. Goodbye for now.